Jupiter is the fifth planet from our Sun and is, by far, the largest planet in the solar system, more than twice as massive as all the other planets combined. Jupiter's stripes and swirls are actually cold, windy clouds of ammonia and water, floating in an atmosphere of hydrogen and helium. Jupiter's iconic Great Red Spot is a giant storm bigger than Earth that has raged for hundreds of years. Did you know? Why does this storm never disappear on Jupiter? The storm on Jupiter that you are referring to is called the Great Red Spot. It is a huge, persistent, high-pressure region that produces an anticyclonic storm. It is so big that it could swallow Earth whole. It has been observed since at least 1665, which makes it one of the oldest and most enduring storms in the solar system. Jupiter is a gas giant planet that has no solid surface. This means that there is nothing to stop or slow down the winds that power the storm. The storm is essentially a giant vortex of swirling clouds that is driven by the temperature difference between the warm interior and the cold upper atmosphere of Jupiter. Jupiter rotates very fast, completing one revolution in about 10 hours. This creates a powerful Coriolis force that deflects the winds and makes them spin faster. The Coriolis force also prevents the storm from moving much from its position near the equator. Jupiter has a very complex and dynamic weather system that involves multiple jet streams, belts, and zones of different colors and temperatures. The Great Red Spot is located in a region where two jet streams flow in opposite directions, creating a shear zone that stabilizes the storm and prevents it from merging with other storms. Jupiter has a very strong magnetic field that generates intense auroras and interacts with the solar wind. This may also affect the atmospheric circulation and chemistry of the planet, and possibly influence the color and composition of the Great Red Spot. The storm on Jupiter is a very unique and fascinating phenomenon that has been puzzling scientists for centuries. It is not likely to dissipate anytime soon unless something drastic changes in Jupiter's environment or internal structure. It is one of the wonders of our solar system that we can admire from afar. Jupiter's position as our solar system's largest planet is truly earned. You could fit 11 Earths along Jupiter's diameter, and in case you were looking to fill up Jupiter with some Earth-size marbles, you would need over 1,300 Earths to fill it up, and that would still not be quite enough. However, despite its awesome size, Jupiter's true rule over the outer solar system comes from its enormous mass. If you took all the planets in our solar system and put them together, they would still only be half as massive as Jupiter all by itself. Jupiter's mighty mass has shaped the orbits of countless comets and asteroids. Its gravity can fling these tiny objects towards our inner solar system and also draw them into itself, as famously observed in 1994 when comet Shoemaker-Levy 9, drawn towards Jupiter in previous orbits, smashed into the gas giant's atmosphere. Its multiple fragments slammed into Jupiter's cloud tops with such violence that the fireballs and dark impact spots were not only seen by NASA's orbiting Galileo probe, but also observers back on Earth. Jupiter is easy to observe at night with our unaided eyes, as well documented by the ancient astronomers who carefully recorded its slow movements from night to night. It can be one of the brightest objects in our nighttime skies, bested only by the Moon, Venus, and occasionally Mars, when the red planet is at opposition. That's impressive for a planet that, at its closest to Earth, is still over 365 million miles, 587 million kilometers away. It's even more impressive that the giant world remains very bright to Earthbound observers at its furthest distance, 600 million miles, 968 million kilometers. While the King of Planets has a coterie of 95 known moons, only the 4 large moons that Galileo originally observed in 1610, Io, Europa, Ganymede, and Callisto, can be easily observed by Earth-based observers with very modest equipment. NASA's Juno mission currently orbits Jupiter, one of just 9 spacecraft to have visited this awesome world. Juno entered Jupiter's orbit in 2016 to begin its initial mission to study this giant world's mysterious interior. The years have proven Juno's mission a success, with data from the probe revolutionizing our understanding of this gassy world's guts. Juno's mission has since been extended to include the study of its large moons, and since 2021, the plucky probe, increasingly battered by Jupiter's powerful radiation belts, has made close flybys of the icy moons, Ganymede and Europa, along with volcanic Io. As Juno flew within 220 miles, 354 kilometers, of Europa at 2:36 p.m., PDT September 29, 2022, JADE identified and measured hydrogen and oxygen ions that had been created by the bombarding charged particles and then picked up by Jupiter's magnetic field as it swept past the moon. Back when NASA's Galileo mission flew by Europa, it opened our eyes to the complex and dynamic interaction Europa has with its environment. Juno brought a new capability to directly measure the composition of charged particles shed from Europa's atmosphere, and we couldn't wait to further peek behind the curtain of this exciting waiter world, said Salai. But what we didn't realize is that Juno's observations would give us such a tight constraint on the amount of oxygen produced in Europa's icy surface. Juno carries 11 state-of-the-art science instruments designed to study the Jovian system, including 9 charged particle and electromagnetic wave sensors for studying Jupiter's magnetosphere. Our ability to fly close to the Galilean satellites during our extended mission allowed us to start tackling a breadth of science, including some unique opportunities to contribute to the investigation of Europa's habitability, said Scott Bolton, Juno's principal investigator from the Southwest Research Institute in San Antonio. And we're not done yet. More moon flybys and the first exploration of Jupiter's close ring and polar atmosphere are yet to come. Oxygen production is one of many facets that NASA's Europa Clipper mission will investigate when it arrives at Jupiter in 2030. The mission has a sophisticated payload of 9 science instruments to determine if Europa has conditions that could be suitable for life. Now Bolton and the rest of the Juno mission team are setting their sights on another Jovian world, the volcano-festooned moon Io. On April 9th, the spacecraft will come within about 250 miles, 16,500 kilometers, of its surface. The data Juno gathers will add to findings from past Io flybys, including 2 extremely close approaches of about 932 miles, 1,500 kilometers, on Deck 30, 2023, and Feb 3, 2024. NASA's Jet Propulsion Laboratory, a division of Caltech in Pasadena, California, manages the Juno mission for the principal investigator, Scott Bolton, of the Southwest Research Institute in San Antonio. Juno is part of NASA's New Frontiers program, which is managed at NASA's Marshall Space Flight Center in Huntsville, Alabama, for the agency's Science Mission Directorate in Washington. The Italian Space Agency, ASI, funded the Jovian Infrared Auroral Mapper. Lockheed Martin Space in Denver built and operates the spacecraft.